Hello scholars, something a little different for our notes today. Not exactly what I had originally planned. So what I'm going to ask is that you follow along as best you can. We've talked a lot about how not everyone has a printer at home and is maybe not able to copy or print this out rather. Do the best you can to follow along and watch what I'm doing. A copy of this paper is attached to Google Classroom. Lesson 3 problem set, it should say 6-3 problem set. You can go ahead and download that, print it, work along with me in this video. You can also pause it on this screen and try to copy this onto graph paper, but it's a good deal of work, so I'm not asking you to do that necessarily, just it's an option. If all you are able to do is watch this video and follow along with what I'm doing, that's great. Try to pause before I start to do something maybe, and even on your screen try to look and see where you would put it. I just want us to work through this together, talk through it together. Class is going to be the same tomorrow. There will be a sheet that says Lesson 3 homework. I'm going to attach that to this video as well. They're going to look very similar. Problem set I'm showing you now. Homework I'll show you in class. If you can print and follow along, that's awesome. If you can't, it's okay. It's okay. All right, that all being said, we're going to use the grid below to complete these tasks. Now it says construct an x-axis that points through A and B. Now to do that, we have to locate A and B. So there'll be a lot of zooming, I have a feeling, today. Looking here, I've got A, I've got B. Okay, they're already horizontally lined up. That's nice. So I will go ahead and connect these two. Use my pencil. There we go. Do a nice horizontal line there. Okay, and I will label it x-axis. All right, so we have an x-axis that passes through points A and B. Now, technically, it would go forever that way and forever that way, but I don't think we need to do quite that much. Okay, the next step. Construct a perpendicular y-axis that passes through points C and F. Now, the paper has immediately proven me wrong. C and F are over here. So if I draw a line, and I've learned, I see where this is going, so I'm going to do it a little differently this time. If I draw a line all the way down like that, my x-axis does not go over quite far enough. That's okay. We will fix that right now. So again, I'm going to use my ruler. There we go. We'll extend the x-axis. Okay. Now the reason why I want to do that is because I know, first of all, the x-axis and the y-axis, these are going to intersect. If they don't intersect, I don't have my origin, and it makes it a little trickier to go through and do what we need to do. Y-axis, right there. And I will go ahead and extend the x-axis so I can put an arrow there as well. Again, I want to make sure we're doing this properly. Okay. There we go. Okay, tilt it a little bit, but we'll fix it with the arrow. X-axis. Now, honestly, if you're working on just a piece of line paper, white paper, anything, you can just draw an axis like that, no problem. Okay. Axes, like this, I should say. Now, we've constructed an x-axis that passes through A and B. We constructed a perpendicular y-axis that passes through points C and F. Label the origin as 0. We've talked before, the origin is where these two axes intersect. So it's going to be right here. It's going to be this point here. Now, normally, all you need to do is put a little 0 in the corner because it means we haven't traveled at all along the x or the y. It's the origin, it's the start, it's nothing. Now, the x-coordinate of B is 5 2/3. So this is 5 2/3. That is what D is telling me up here. So it says label the whole numbers along the x-axis. Well, oh boy. Okay, so if this is 2/3, and I've got way more than 5 spaces. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17 spaces. Oy. 17 spaces. I have to figure out what I'm breaking them down into. Now, we've got a couple of tricks up our sleeve to figure this out. Since this is 5 2/3, thirds seems pretty likely as our individual unit. Third. There's something else we can do to check. 3 times 5 would be 15. Plus 2, 16, 17. 17 over 3. How interesting, since I just counted 17 little jumps a moment ago. Here's our confirmation. If this is 17 thirds, then that means each of these is 1/3, which means every 1, 2, 3 is a whole number. Now, if I counted 3, why would I put a 1 there? 1/3, 2/3, 3/3 makes 1. 1 1/3, 1 2/3, 1 3/3 is going to be 2. Jump another 3. Technically 9/3 would be 3. Jump another 3, there's your 4, 12/3. Here's 15/3, and we can check. 15/3, 16/3, 17/3. So every little box is 1/3. We'll label the whole right there. Okay. Now, we're going to have to do something similar for the y-axis. We're going to do something similar for the y-axis. It tells us the y-coordinate of C is 5 1/3. 5 1/3. Okay. So I'm going to assume that this is counting by thirds again, but I better make sure. 3 times 5 is 15 plus 1 is 16, so I'm thinking 16/3, starting at the origin. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16/3. Yeah, so we're good. Okay, so this one should go a lot faster. 1, 2, 3, there's your 1. 1, 2, 3, there's 2. 1, 2, 3, there's 3. 1, 2, 3, there's 4. 4 1/3, 4 2/3. 4 3/3 would be 5, and then 5 1/3. Okay. Now, why did we do this? Why did we do this? The whole point of doing this is so that now we can take a look. We have a coordinate plane. We have a coordinate system, 2 coordinate systems set up in a plane. We can figure the exact location of these various letters. So if I ask you, what is the coordinate location? What are the coordinates for L? I'm going to make sure that's centered in the screen as much as I can. I'm going to try to make it a little bit bigger if I can. The camera might not let me make it too much bigger than that without cutting part of it. If I ask you what L would be, you're going to start by counting across the bottom, and I would suggest just jump to the holes. 1, 2, 3, 4, 5. I'm going to follow that line up. And it is on that line. If it hadn't been, then I would have gone down to 4 2/3, 4 1/3, or up 5 1/3, 5 2/3. Okay. But this does line up very nicely with the 5. So L is 5, comma, something. That's our x. We need to find our y coordinate. Just trace over and see where it stops. 5, how convenient. 5, 5. Now we'll try a different one. Let's try E, not exactly going in alphabetical order here. Okay. E, I look straight down, and I see that this stops right about here, which is a little before the 1. That'd be 1/3, 2/3. So the x-coordinate for this is 2/3. 1/3, 2/3, and then up some distance. Well, let's look over and see how far up it's gone. 1, 2, 2 1/3, 2 2/3. The x is how far over it is on the x-axis. The y is how far up it is along the y-axis. X, then y. Now, I'm sorry, I keep accidentally pointing to that, but again, 2/3 by 2 2/3. There's your location for E. We are going to be doing something very similar to this in class. I know I keep repeating myself. If for some reason you are not able to print this at home, I understand. I understand. Hopefully you follow along with the video. You were able to kind of pause and look and see what I was doing, figure these out as we went. I would challenge you to pause the video in just a few seconds and try to figure out what would be the coordinate pair for M. What would be the coordinate pair for K? Okay? Practice with that. Even if you can't do it on paper, you can at least do it on the screen. I will see you tomorrow in class. We'll go over some of this. We're going to look at another one that is very, very similar. So if you can print out homework for lesson 3, that's what we'll be doing in class. All right, ladies and gentlemen, I will see you next time. Thank you.